Okay, good evening. It is day 51 of coding every day. Won't lie, today's probably gonna be my shortest video ever. Because wait, Bop. Today's probably gonna be my shortest video ever because I want to watch this Bills Ravens game really bad, and it just started. And if you watched any of my previous videos, you knew I went home for the weekend from my apartment. So this morning was me packing up and driving back to this apartment. And I got back here and then I watched the Commanders game, not Commanders game, the Rams versus Eagles game, and now that just finished up, and so here I am. So we're probably just gonna do one quick leak code. Hopefully it's quick. I really hope it's gonna take me a while. Um, and actually, I'm gonna cap it at like 20 minutes, and then we'll outro this, and I'll talk about what I want to do this week. Because tomorrow's Monday, and today's my last. This week is my last full week until school starts again. I still have some more days off the following week, but it's not. That is the week I go back to school. So, so yeah, so a lot of stuff I hopefully want to get done this week before we go back to school, and that's my primary focus. So yeah, let's find a leak code to do. uh, um, let's do another greedy one. Now here's the thing: I still need to get better at um, greedy stuff because right now I'm not gonna do a greedy search here because like I don't know actually how to do like off the top of my head, like I can't envision what a greedy search is right now. I assume I mean last time uh it was something that was like a hard boundary, right? If there's ever something that was lower here, I'll show you what I'm talking about. I think this was the same section. Yeah, it was if there was ever something like a sum. So this was given any subarray, what subarray has the maximum sum if you added all of them together. So any you take any group of these numbers in a subarray and um and it has to be in a sequence. Um and so the whole thing was like if at any point you go negative, you just cross out everything behind that. And the idea is, if this is negative, there's going to be no point ever where we want to add, you know, those values because it's just going to um it's always going to bring down the overall value of this if this isn't also already negative. um so yeah so yeah okay, but anyways, we're doing not that one. We are doing the next one. So you're given an integer array nums where each element at nums of I indicates your maximum jump length at that position. Return true if you reach the last index starting from index 0 or false otherwise. Okay, so each element is how far we can jump in the array, and we want to see if we can make it to the last index. So explanation, we jump from 0 to 1 because this is 1, so starting at 0, we can jump to here. From index 1, um, we can go, I guess, so this would mean I could either, so this is maximum, so I could either go 1 or 2. If we went 1, that'd be we can't move, and then 2, so we can move one more, and then I can do one move to the last, so it's true. Here, I can move 1 here, so we move to 2. If I move 2, it's a 0. If I move 1, it's a 1, and then we can't move. Okay, okay. Pretty straightforward. How would we solve this? So we just want to know at a given position if we have reached, I guess this would be recursive, right? Because we want to know if we've reached a base case, and base case would be that given an incremental change, our index is equal to the last index, right? Um, so so if we have, wait, did I ever? Oh, for a second I thought I left my cam like enlarged in the center. Um, so if we So if we given we're starting at index 0, right? If at index 0 we say we go through and we take nums at I and we say, okay, if we were to go and then we step through every single possible. So this is the whole thing with the greedy thing, right? Is what I did last time is I iterated through every single possible subarray. So this would be every single possible jump is what. So this is the pattern is that you're trying to get rid of that whole searching for every possible way. There's some trick here of like I can know before I can know to stop looking at a certain point or something like that along those lines. But anyways, that's not how we're going to solve it. We're going to solve it at looking at every single possible way. So it would be at any given index, we need to iterate through the possible jumps we can make and see if we can hit the last index, right? Um, okay. Ah, so we know we want this to be recursive. So it's going to be um, jump, and this is going to take in just an index, and we're just going to call jump with that index 0. Now this should be we need our base case of okay, if index is equal to nums at um well no it'd be the length of nums minus 1, right? Because we want index, not value. So sorry about that. So if this is equal to that, then return true, right? Otherwise, so at each iteration, we want to check from index to the max. So we need to know a stopping point, right? Because it's not till the end, it's to the max, and then we have to loop up until that max, right? So we need to say the stop is equal to what? The stop would be equal to just the current value plus our current index. So if we're at index, say, 1 right here, and we know we can go 2, our stopping point is going to be 1, 2, right? I mean, yeah, it should just be stop equals nums at index plus index, right? Yeah. And then for um say for k in the range from index to stop, this is where we do our recursive call, right? If jump, wait, wait. From index, so if I'm at index 1, right? Stop is going to be at current index plus wherever we're going. And so we want to see every single possible iteration given whatever. So it's going to be with k, right? But no, wait, I'm missing something here. If it's like right here, if we're on index one, right, and we know the stop is at here, right? When we're looping through, starting at this index, we're just gonna go to this index and do its check, and we're also gonna do this index and do this. So when we get to this one, right, and it says, so we'll end up passing through the current index. Yeah, so it would be this. But we want to say if this, right? Because if this hits the base case, then we want to return true. Um, and then if none of that happens, oh my God, then we return false, right? Am I missing something here? Huh? How would that be maximum recursion death? If index, what? How is that a maximum? I don't get this. Why is this doing an infinite? Wait, one thing I want to check is if, no, it should be fine. Oh, I see. Wait, why do I want to do? Why would I want to do stop plus one? Let me just see with an index plus one. My output was none. Why was my output none? return true. How could this ever be? What? I'm gonna check these DMs real quick. But okay, I don't understand how this would be none. For loop does not execute return true for any iteration. I mean, I have a return false. I have a return false. Oh, true. True. I see. There we go. There we go. Okay. But this was stop plus fucking one. It was. Why? That's the only thing I need to figure out about this is why that would ever be stop plus one. If stop is equal to whatever this is, right? So it's nums at index, which here would be 2, plus the current index, which is 1. So 3. So it's 3. So then this is 4. Oh, because is it because it's let me print stop. Well, actually, let me print K. Let me print K. Because ideally, and then let me also print off stop. Here. Stop K value. No, it does. It is inclusive. But like so if I'm here, right? I mean, I guess it but isn't that like an index out of bounds? Oh, but we just hit the base case, so it doesn't even matter about right? Like I'm pretty sure it would always hit the base case, so the index out of bounds wouldn't even matter. Okay. Yeah. So what was the greedy search one? So we have the goal is the last index, yeah. Then we loop through nums minus 2, minus 1, minus. I didn't even know this is a valid range. If I plus nums at 1, yeah, is greater than or equal to the goal. So if the current jump value at its index is greater than what we're trying to get to, goal is equal to I, and we return goal. Uh, I don't know what this does, but yeah, that is pretty simple. If the current goal, But what? Wait, I don't get that though, because like, what if it has to be something in this, right? Because it's like, if we're at I plus nums at I, right? Which is let's say it's zero, right? We can't go anywhere, but there's still more elements. So what would that even mean? It has to be in how this range thing works. Anyways, I don't have the time for all this. I need to go watch this football game. Um, but at least we got the problem done relatively quickly. I'll look into that range thing after this I end this recording. Because that's interesting. I don't understand how that's like avoiding the whole I can't move anywhere, or I can't get to the end. Um, but anyways, yeah. So this week, the plan is finishing the base version of Code Visualizer. That is the landing page, the login page, the main page, the functionality, all of that, the history, all of that done this week. A fully working application, not deploying yet, right? I'm still gonna sit it behind. The landing page is still going to be um the landing page is still going to be the collecting emails thing, and I'll nullify the register button so you can't register. And I'll also make sure I'll have to do something because then you could technically do like Postman and put yourself into there, I guess. I think that's how that works. Anyways, um, yeah, so getting that done and getting it like set up to like advertise it, I guess, without actually deploying it. Um, so that's number one that I want to get done this week. Two lead codes a day, one or two, ideally two every single day this week. Um, what else? What else? I'd say I'd like to get to 225 total internship applications by the end of the week. That would be another 50, I believe, something like that. And then maybe work on the CLI tool a little bit. Oh, and plan out the semester long project that I want to do. Whatever that is, whatever I think would be most fun and beneficial to my skill set, I guess. So yeah, anyways, sorry for the short one. At least we got something in. We got a successful LeetCode in. But I will be back tomorrow for day 52, and that's about it. So I will see you then. Okay, take care. Bye.